In my last video, I have told about the preventive maintenance, that what is the preventive maintenance. In this video, I am going to talk about under what constraints it can be applied. So how this preventive maintenance can be applied, what are the constraints to apply this preventive maintenance. We have preventive maintenance, the reliability for the from preventive maintenance as in the form of we represent it in the form of Rm of t, and R of t is the reliability at time t is equals to unknown. So the reliability of preventive maintenance when performing a maintenance, the reliability when performing a maintenance at time t and the reliability at time t are the two things that are unknown. Okay, so we have different, you can see different reliabilities when we perform the maintenance. So what we got and what are the changes in the equations. For this we have a diagram. For this we have a curve. This is our reliability. This is our reliability of performing a maintenance. It is also bounded between 0 and 1. 1 and 0. It is bounded between 1 and 0 at time t. So what happens when we go from 0 to t0, and then we go from t0 to 2t0, then we go from 2t0 to 3t0. So these are the conditions, these are the possible values just to represent our reliability when we are performing the maintenance. So this can be written in the form of like this: Rm of t is equals to R of t. First equation would be Rm of t is equals to R of t, and when it happens, when Rm of t is equals to R of t, it is when our reliability at time t is from 0 to t0. When we have from 0 to t0, from here to here, we have a condition that our Rm of t is equal to R of t. Got it? And the other what it said, that Rm of t is equals to Rt0 Rt minus t0. So what when it happens, when this equation comes in, when we have a limit from t0 to 2t0, when we are here t0 to 2t0, we have a equation in the form of like this. Okay, and the third one is when we are in the limit from 2t0 to 3t0, we have the equation in the form of like this. You can see it easily. Rm of t equals to Rt of 0 R t minus t0. The other one is Rm of t is equals to R2 t0 R t minus 2t0. And the third is Rm of t is equal to R I t0 R t minus it0. So this is when we have a limit from it0 to I plus 1 t0. So when we have this kind of limit, what happens, we have the equation in the form of like this. So you know that now we say that this reliability of performing a maintenance can be greater than the reliability of an item. It can be lower than the reliability, or it can be equal to the reliability. It's just that when we have the maintenance, when we have the reliability of maintaining a component is lower than the actual reliability, so it is considered as damage. Because why it is considered as damage? Because it is no use of performing a maintenance here. When we got the reliability of performing a maintenance less than the present reliability, so it is not no use to useless it is useless that we perform the reliability of maintenance. It is useless because what we get a reliability that is considered lower than the actual reliability, than the present reliability. So that's why when it is less than R of t, when we call it damaged. Okay, so let's see what's next. And we also say that this Rm of t over R of t is greater than 1. It can be equal to 1. Sorry, this is less than 1, and it can be equal to 1. So we have three conditions, that Rm of t over Rt is can be greater than 1, can be equal to 1, and can be lower than 1. We have these three conditions, right? Now under these conditions, what we did now, we say that Rm of t over R of t equals to, here we keep the value for Rm of t, what it was this is for all i's, okay, these are all i's that are going from t going from 0 to so on. So this is for all i's we have, that's why we are taking this equation. We keep this equation here in the place of Rm of t, and down there we have R of t. We know that R of t, the reliability at time t, is equal to E at the minus lambda t. So the reliability can be written in the form of this also. So we replace here, see, in the place of Ri t0, we wrote it as E minus lambda I t0, right? And here in the place of Rt minus it0, we remove it, we replace it as E minus lambda t minus it0. So this remains here, and only lambda comes here as R of t is E minus lambda t. So in the place of t we have this. Here also in the place of t we have I and t0, so it comes here, and here we have R of t, so we have R of t as E minus lambda t, so it remains here in the same way. So now what we get now, we have this, and we multiply by lambda and t, we got minus lambda t, and minus plus lambda t0. Lambda I t0, lambda I t0, they both are minus and plus, so they goes away. Okay, they both are cancelled, and what remains, what we have, they are not cancelled, they are one is positive and the other is negative, so it would be e to the 0, and e to the 0 is 1, and we have e at the minus lambda t remains here, and e at the minus lambda t remains here, so they both also cancelled out, and what remains here, 1. So the answer we got is 1. So what did we find out? That our Rm of t over R of t equals to 1. So we have find the thing that we said before. We said that it can be greater than 1, less than 1, or equal to 1. The thing that we said that it can be equal to 1, we have proved it by our calculations, by our equations. We have proved this thing. Now what we say, this is the first part. We have proof Rm of t over R of t equals to 1. We have proved it. This was our first part. Now what we say, that when performing maintenance, mistake can be done. So this is the actual thing. First we say that we are performing a maintenance on a component. Then we say that when we are performing maintenance, it is obvious that during that maintenance a mistake can be done. As being a human being, mistake can be done by anyone. So that's why we are taking the mistake here, that when the mistake is done, what happens when a mistake is done? We take P is the probability of making a mistake. So we bring a new thing, what we say it as a new alphabet. We bring P here, which is the probability for making a mistake, right? The probability of making a mistake, we write P here. So what we say now, we have Rm of t, you know that R of t0, R t minus t0. It is when it is, this equation is when we have a limit of t from t0 to 2t0, and yeah, we have a probability of making a mistake. P is the probability of making a mistake, and you know P is bounded between 0 and 1. P has the limit from 0 to 1, right? Now we have, you know that we have this formula, Rm of t is equals to R of t0, Rt minus t0. See, this was the first one when we not the first one, the second one, when we have the limit for t equals to t0 to 2t0. So we wrote it this, but what is now happening here, what is the new thing that is happening that we are talking about when making a mistake. So that's why we multiply by p. P is the probability of making a mistake. So in the same way, when we wrote it as in the form of I, Rm of t equals to Ri of t0, R t minus t0, we also multiply p here, that is the probability of making a mistake. So this was when t has the limit from it0 to I plus 1 t0. Okay, now what we did now, we bring p here, and these are all i's, so it can be written in the form of this, and this is not only t0, this is it0, right? it0, and p comes here, p is written in the form of pi, and rest remains the same. Okay, we have all i's here, so that's why we have to write p also in the form of I. And now what we have, now we do the same thing like we did before. Rm of t over r of t equals to, we write all in the exponential form, because you know that the reliability, to write the reliability, we can write it as in the exponential form. So the pi would become e at the minus ip, and this rit0 becomes e at the minus lambda. You remember r equals to e at the minus lambda t, so this is t, so minus lambda it0, and this is rt minus it0, so this becomes e at the minus lambda, and this thing is t, so t minus it0, and the rest down there is r of t, that is e at the minus t. So this e at the minus t here, and what is next? This minus lambda it0, and this also becomes lambda it0 plus, so they both goes away like we did before, and what remains? E at the minus lambda t over e at the minus lambda t, it also cancels out, and what remains? Only this thing remains. So Rm of t over r of t when making a mistake. When we are making a mistake, so it is in the form of this, e at the minus I p. So that's all for this when making a mistake. Now what we talk about? Now we talk about the PDF, Weibull PDF. We take a formula for the Weibull PDF. You remember that first we have find when Rm of t over r of t equals to 1. Now we are going to work through, we won't be considering the less one because that is damaged, we don't need to consider it. Now we have to go through the Rm of t greater than r of t. So how can we find this thing? What we find that when Rm of t is greater than r of t, let's have a look. So we have here a PDF, that is e to the minus 0 to t, limit of 0 to t, h tau and d tau. Right, we have a Weibull PDF. Whose Weibull PDF? What is the Weibull PDF? We have a formula beta over eta, t at the minus y beta minus 1, e at the minus t minus y over eta at the beta. So this is our Weibull PDF. If anybody don't know what is Weibull PDF and what else it is, you can search it and go through the other videos also. So this is the Weibull PDF, and why we have you know that we always have t0 here, but here it is y. We have y here because in the above we have kept this t0, we have taken this t0 everywhere, so we can't take that same t0 here also, because it would be the mixed match condition, so it would be matching things would going to happen. Okay, now what's next? We create a Weibull PDF here. So this is our Weibull PDF. Now what we say, that we have to find out r of t. What is our r of t? R of t is written in the form of exponent. So we consider this thing as our r of t, because r of t is always written in the form of exponent. So we consider this in the form of r of t, So here it comes. What we did now, just to simplify our equation, we suppose y equals to 0 when y becomes 0. So r of t is now e at the minus t over m at the beta. So this is our r of t. R of t comes in this way. Right, now what's next? Now we will be creating this equation Rm of t over Rt. We will be putting it in the form of like this, and what we got, this was Rit0. So when we take Rit0, this is e at the minus I, and instead of this, you remember this is now t here, so it would be t0 over m at the beta. So this is replaced now in the form of like this. Got it? And for t0 we have t0 and others are being replaced in the form of beta and eta. Right, now we have e at the minus t minus it0. So e at the minus t minus it0 remains the same, and beta over eta is being added. So these things are being added here, right, and rest is r of t. So we have found the value for r of t, that is this. Now what happens? Now we say that we suppose that our t is equal to it0. When we suppose t is equal to it0, so we substitute the values for t. Here it comes it0, and here also it comes it0. This cancels by this. When this thing cancels, it becomes 0, and e to the 0 is 1. So this is removed. In this way, this thing removes. Now we have what we have left. This is left and this is left. They both are left. Now we need to work on these two. So what we did, we bring this down equation to the upward direction. We bring it to the upward time, and after bringing it up, what happens upward? We got the equation in the form of this, and when we got the equation in the form of this e, you know that when we have greater than 1, we can write it in the form of this e is represented, the e's are the both same, so it can be one e can be removed and it can be represented in the form of plus and the other exponential form, exponential thing value. So it is here in the form of adding, and this is what we called is equal to greater than 1. This is, we say that this equation is greater than 1. The equations that are in the form of exponent, they will be considered as greater than 1, and when we remove the exponent, then the equation would be considered greater than 0. So see, you can see this, when we remove the exponent, so the equation can be considered now in the form of greater than 0. This equation is being called as greater than 0. First it was greater than 1, now it is greater than 0. So what it remains, t0 over eta at the beta plus ib t0 over eta at the beta greater than 0. So this is the thing that remains. Now what's next? We took the common from all these equations. When we took the common from this, here what is the common? t0 over eta at the beta is common, so it would come out, this is the common, t0 over eta at the beta is common, and what remains here? Only ib remains in this part. This is positive, so it would be in the first part. ib remains here, and minus 1, so minus 1 would be here, and this is, we are saying, is greater than 0, and we named it as equation 1. Now we say that this is also greater than 0 and this is also greater than 0. We say it like this. So we are going to take this thing, we took it, ib minus 1 greater than 0, and it can be written in the form of this also, I to the b minus 1 greater than 0. This can be written as this as well. And when we say that I to the b minus 1, it goes there and can be represented, I to the b minus 1 is greater than 1. So this is our desired thing that we got when we have the reliability, when we have the maintenance of performing the reliability greater than 1. So we have got this equation here. Now we say that probability of not making a mistake. So there can be two conditions. We perform maintenance, and after performing that maintenance there can be two conditions that can happen. One is that when we do a mistake, and the other is that when we did not do a mistake. So this is the probability of not making a mistake. We write the probability of making a mistake as P. Now we are talking about not making a mistake, so we will be representing it as 1 minus P, and at the I it's the same that we did before. You remember, in the form of like this: P at the I, Ri of T0, and so on. So here it is also written in the form of like this. Here we have wrote it directly, Rm of T, R of T, because it's so easy. It's the same as before. You must know now how to write this thing. So 1 minus P at the I, Ri of T0, R T minus IT0, R and T, R of T. So that's it. So now what we are going to do, we'll replace the reliabilities in the form of exponential form. So I T0 over eta at the beta, and E minus T minus IT0 at the beta over eta, and this becomes E at the minus T over beta over eta at the beta. And what comes now, we say that T is equals to IT0. We say this like this. So in the place of T we will replace IT0, IT0, IT0. So this goes away. E at the 0 is 1, and it remains like this. Here it is in the form of like this. Now what we find out, we find two things. This was for there was no mistake happened, and this is for performing a mistake. They both are, we have got these two things. Now what we are going to do, what we say from equation 1. Where is equation 1? Yeah, equation 1. We took this equation greater than 0. We took this because we are working on greater than 0. So we will take this greater than 0 again, and we will talk about it now. We say from equation 1 what we got. E at the minus IP we put here, and rest remains the same. We create this equation: E at the minus T0 over beta over eta at the beta IB minus 1. So what happens, this is we wrote it in the form of E because this was also in the form of E, so we wrote it like this, and we say it as greater than 1, because when we say greater than 1, when we have the equation in the form of exponent, so we call it as greater than 1. So after representing it to greater than 0, what becomes, these e's got replaced, these e's got neglected, and it comes here in the form of this: E at minus IP plus, it won't be 0, it won't be minus, because here it is T0 at the eta. So where it is, okay, it's not minus here, it's erased, but it's still not erased in the good manner. So this is not minus here, no minus is present, don't got confused. It's the same thing as we wrote it here. It's the same equation. T0 over eta at the beta, I beta minus 1. We have just replaced here. So it was when greater than 1 and when greater than 0. These exponents got erased, and plus T0 eta at the beta, I beta minus 1. So this is also the method for writing the exponents, when we wrote the exponents, two exponents, so their upper terms are being added. So that's why we have an addition sign here. And now what we did, we removed this I from here, and we got P plus T0 over eta at the beta I beta minus 1 greater than 0. So we provide this we write this I beta minus 1 in the form of like this, and for that we remove this I from here. I think that it is being common, I is being taken as common, and when it is being taken as common it goes there and it is neglected, right? So what remains? Minus p plus t0 over eta at the beta I beta minus 1 greater than 0. So this is the thing what remains, and we can say that this probability can be less than this equation when beta is greater than 1. So probability is of making a mistake, so it can be less than probability of making a mistake. We have proved that the probability of making a mistake can be less than this one. So our scenario, our condition of making a mistake can be much less when we have a beta greater than 1. So that's for all for this part. Now we have entity of M and entity F. We also have to find this, as you know that when we have found the Rm of t and R of t, it is our duty that now we have to find the mean time to failure. After finding the reliabilities, we have to find the mean time to failure. So here also we are going to find the mean time to failure of maintaining our item, of preventing our item and performing maintenance on it. So what it can be written in the form of like this: entity of M over entity F, as we say R of M, Rm of t over R of t equals to. So this is the formula, this is the equation for entity F of M and entity F. It's same, but just the M is added for the maintenance. So it is from limit going from 0 to infinity Rm of tau and d tau, 0 limit going from 0 to infinity R of tau and d tau. And you know that we have Rm of t in the form of this. We have Rm of t from 0 to t0 and t0 to 2t0 and 2t0 to 3t0 and plus so on. So that's why we have written it like this, because we have our t in the form of like this. It has different limits, so we have integrated it in the form of this. Okay, and we have another I. So I is also it would be also written here. It is the sum, that is I is the sum going from 0 to infinity, and we have a limit at I. We have the limit, we have the limit from I t0 1 plus I plus 1 t0. Remember we have this, where it is, remember we have this, we have a limit for t, that is I t0 to I plus 1 t0. So this is the limit of t when we are talking about I. So that's why we have written here in the form of I, R tau and d tau. So this can be written in the form of like this. But when we do it for R tau and d tau, when we do it for this, we have to write the sum, because you see that these are the sums. We can't write only the limit, we have to provide these sums also, because Rm of t is not only the I term, it is from 0 to t0, t0 to 2t0, 2t0 to 3t0. So that's why we have written it in the form of sum. And what is the sum? That is that I going from 0 to plus so on, so 0 to infinity. That is the sum, and that is the limit that has been written here. It's so easy. It's just the, if your maths is good, if your calculations are good, and I'm telling you each and everything, each and every step in a really precise and clear manner, so you should, I hope you won't be having any problem afterwards. Okay, now we have got this value. Now we are going to write it in the form of MTTFM and MTTF. MTTF remains 0 to infinity I tau and d tau, and this remains here in the form of here. These are both the same. Okay, now what's next? We have now we'll be writing this R tau and d tau. R tau in the form of this that we did before. So what it is? It is Ri t0 R tau minus it0 and d tau. And now why we have kept this tau here? Why not the t? Because we are talking about the tau. We are integrating it with respect to tau, not the t. So that's why we have replaced this t in tau, and now the rest remains the same, and here they both are here also. And now what we say that this tau minus it0 equals to y. We consider this whole term, this whole thing in the bracket, tau minus it0 is equals to y. So obviously d tau would be d of y. So just to let our equation, our calculation easy in a simpler method, we assume these terms equals to y. So what happens next? After when we assume these values as y, the equation becomes I going from 0 to infinity, and the equation becomes from, and the infinity becomes from 0 to t0 ri t0 r y dy over infinity limit that is going from 0 to infinity r tau and d tau. So this it becomes like this when we assume tau minus it0 equals to y. So we have got the limit of 0 to t0. Now what we can do now, we have do this. We see that now we can simply do the integration of ry dy, and we can do these integrations together. We can do this in the form of integration, because this is integration. This integration sign would be should come here. So that's all what we do. We put it here, the sign, integration sign here, ry and dy, and rest this and this remains here. And what is next? 1 minus rt0. Okay, and this is here 1 minus rt0. Why this 1 minus rt0 is here? Because when we put this thing here, so this is the method of writing this as 1 minus rt0 in division. So that's why it's here. This is the way of, when we put here, this is the way of writing this here. Okay, so now what's next? What we say now, we have 0 to infinity, and what changes? Yeah, this thing changes, this thing cancels out, this thing goes away. I going from 0 to infinity, this thing goes away. When this thing goes away, 1 comes here. Okay, because we have only the t0 and no i's are present, no there is no nothing like I. So that's why we have here 1. So that's why we have 1 here, because we have a limit from 0 to t0 only. So that's why this r, I and this sum goes away, and we have 1 here. And now we are going to integrate it. We are going to integrate this term and this term. So what happens? First we are going to write it in the form of exponent. rt0 becomes e at the minus lambda t0. This ry becomes e at the minus lambda y, and this r tau becomes e at the minus lambda tau. And what happens next? Now this is going to integration. This would be integrated. When this integrated, what happens? This minus lambda comes down there. In the form of integration, this happens. The upper term, the what is called the power comes in division. Okay, and this remains the same, and we have to limit it from 0 to t0, and same here goes here. This remains in the same way, and same goes here. E at the minus tau and minus lambda from going from 0 to lambda. Oh, sorry, not lambda, sorry, 0 to infinity. And what's next now? It's just that this 1 over minus lambda comes out. This would be multiplied by 1, and e at the minus lambda, and in place of y we put t0 and the other limit of 0. So in place of y, other limit is 0. The next thing, here is the division. and this thing remains the same here. And for this we have 1 over minus lambda comes outside, and e minus lambda tau. For first limit we have infinity, and for second limit we have 0. So this infinity, this thing goes away, it would be 0, and when we will be writing it as 0, where we will be multiplying lambda to 0, so it would be 0, and we know e to the 0 is 1. First we see that this also e to the 0 is 1, and rest remains the same, right? And this remains here, and this goes away as it was infinity, so it would be 0, and e to the 0 is 1 minus 1, and this, okay. And this thing also, you remember, you know that this was here minus lambda 1 over lambda, so it would be it was multiplying with this also, and it was multiplying with this also. Here is a bracket here, so this goes away, and it would be multiplied by this 1 over minus lambda. E to the minus lambda 0 would be 1, and 1 over minus lambda multiplied by 1 would be 1 over lambda. So it's the same, it's the calculation, integration solution. You can do it by yourself also, it's nothing so difficult. This thing comes here, and what remains, we multiply this whole term together, minus e to the minus lambda t0 over lambda minus minus plus 1 over lambda, and minus and plus 1 over lambda minus e to the minus lambda t0 over lambda. You see that these terms and these terms, they both are equal. So when they both are equal, they would be cancelled out, and what it remains? It remains 1. MTTF m over MTTF is equal to 1. So we have also proved here that it is equal to 1. As we say before that our Rm of t and over R of t is equals to 1. So in the same way, we have proved our MTTF m over MTTF equal to 1. So that's all for now. It has been done. Thank you.